In this section, I will be discussing to you the chemicals, methods, treatments that we'll be dealing with. The chemicals to be used are the calcium chloride, hydroxypropylcellulose, sodium alginate, methylene blue, and distilled water. The methods of preparation of methylene blue solution: to make a 25 ml of 5 ppm methylene blue solution, 6.25 ml of 20 ppm solution will be added to 25 ml volumetric flask, and distilled water will be added to the mark. In making 25 ml of 10 ppm methylene blue solution, the same procedure will be carried out, but with 12.5 ml of 20 ppm solution will be added. Calcium chloride solution with a concentration of 5% weight will be used as a bath during the extrusion of the adsorbent beads. To achieve this concentration, 12.5 grams of calcium chloride will be weighed and crushed further, and then will be placed in a 500 ml beaker and will be dissolved with 250 ml distilled water using a magnetic stirrer. In the preparation of the adsorbent beads, 2 grams of sample containing 75% of calcium alginate and 25% of hydroxypropylcellulose will be dissolved using 100 ml of distilled water. The mixture will be stirred using a magnetic stirrer at 300 rpm for 10 to 20 minutes, forming a colloidal solution. The colloidal solution will be extruded dropwise to the 5% weight calcium chloride solution using a syringe in which the colloidal solution will form solid beads immediately. The beads will be setting in a calcium chloride solution for 10 to 15 minutes to harden. After hardening, the beads will be filtered from its solution and will be washed dry with distilled water. The size of the particle beads will be determined using a vernier caliper before and after adsorption process. The size will then be characterized by their mean diameter by the equation shown. The treatment by the produced beads will be evaluated in terms of percent removal by this equation shown. The adsorption capacity is the amount of the adsorbate that will be taken up by the adsorbent. The adsorption capacity is described as the equation shown. Since the contact time affects the removal of methylene blue from the solution, for the variation of contact time, the absorbent material or the bead will be placed in a 250 ml flask. Then a pre-made 25 ml methylene blue solution will be added separately in the volumetric flask. The beads and methylene blue solution will be stirred using a magnetic stirrer at a rate of 150 rpm. The concentration of methylene blue in solution will be recorded at 30, 60, 90, and 120 minutes, for usually this phenomenon will take a relatively longer time since the methylene blue molecules will reach the boundary layer, diffuse into adsorbent surface, and finally diffuse to the porous structure of the solvent. The pH of the methylene blue solution will greatly affect the entire adsorption process, particularly the adsorption capacity. The pH of the dye solution will be varied from 3.579 to 11 using a 0.1 m sodium hydroxide and 0.1 m hydrochloric acid. In each run, 25 ml methylene blue aqueous solution of a certain pH will be poured into a volumetric flask containing a 0.1 gram of synthesized adsorbent beads. In achieving the desired pH, droplets of 0.1 m HCl or NaOH will be added to the solution, and pH meter will be used to measure concentration of the solution will be determined after the optimum contact time. Adsorption will be highly dependent on the initial concentration of methylene blue solution. It is because of high concentrations the available sites of adsorption become fewer, making the percentage removal of methylene blue dependent on initial concentration. Initial concentration of methylene blue will be varied from 5 ppm to 10 ppm by diluting readily available methylene blue solution. In each run, 25 ml of solution of a certain initial concentration will be contained in a volumetric flask containing a 0.1 gram of beads. Concentration of methylene blue will be examined when adsorption equilibrium is reached.